My question is now, so this is a density matrix corresponding to subsystem of a bigger system. Now my question is, whenever you consider a quantum system, okay, there may be some other system that could be environment or that could be something. I mean, if you consider a system which is not a closed system, let's say, so there will be other systems which it can interact with. That is one point. The second thing is that even if there is no such system which it can interact with, still you can consider a virtual system. That they assume that there is a system in just order to have a mathematical formulation. That this is a part of a bigger system, let's say. Okay, this is a small part of a bigger system. Then the question is, the system which I'm dealing with is a subsystem, okay, of a bipartite system. So now the question is, if I consider any density matrix, so given any density matrix, the question is that, so given any density matrix, whatever it is, it's a rho, or you can say rho 1, okay? Can you consider, I mean, when you say given any density matrix, density matrix corresponds to the system. This is the state of a system. Corresponds to the state of a system. Can you consider it as a density matrix of a bipartite system, of a subsystem of a bipartite system? Now see here, even if you don't consider this one, everything is okay. Whatever we have done, that is perfectly all right. But suppose we want to deal with something where there is a system and we do not know how my system is interacting with the other system. So even if we consider this as the density matrix for my system to deal with, it could be a part of a bigger system where there is another system which is interacting with my system. And this could be just a density matrix corresponding to my system, which is a subsystem of the bigger bipartite system. And then the question is, can this then be written as this for some psi? That means, can rho, this is the question, can this rho 1 be written as this for some psi? What is the psi? Which corresponds to pure state of the bipartite system. Bipartite. So that means what we are trying to deal with is that it's something called a purification of a system. Meaning that I want to, this is a mixed system, but I want to treat my system as a subsystem of a pure state. And then what we can probably do is, we will only deal with this psi. And since this is a pure state, my calculations will be much more simpler than to deal with the density matrix. Okay. So then I will call this psi as a purification of my given system. So this is a purified state of my system because this is a pure state. And I will show you today that this is always possible. That means you give me any density matrix of any dimension, I can always treat the density matrix as a reduced density matrix of a bigger bipartite system corresponding to a pure state. Okay, so this psi can always be found out. Okay, this psi can always be found out. Then the question is, how do I calculate? How do I find such a psi? That's the question. So this entire procedure which I'm going to discuss now, it is called purification of a mixed state. So my input here is and by the way, here you have to notice one thing, that the second system I'm talking about, that need not be, any connection that need not be connected to any physical reality. Okay, it could just be a mathematical formulation. Still, it works. Whether you can use that for your quantum computing part. So this is called the purification of a mixed state. So most of the times, whenever we will say density matrix, we do not specifically mean that it is a density matrix corresponding to a pure state. We'll assume that it is a density matrix corresponding to a mixed state. That's not a problem. So the input is there. So this is only given to me. This row, or let's say row 1. It could be anything. So let us say it is c to the power d1 times d2. d1 times d1. Okay, it's a d1 dimensional system. Then what is my purification? Output, or what is my question here? The problem here? The problem here is to find some psi which belongs to c to the power d1, d2. So d2 is the dimension of my second system, such that rho 1 becomes the reduced density matrix for this psi. Okay, so I have to find the psi. Find psi. This is the question. How to find such a psi for which it is possible. Now, if such a psi exists, okay, if such a psi exists, then what happens? Psi must be written as sum of C I alpha because it must be written as a linear combination of the basis element. So what is I1? This corresponds to the basis, okay, basis of c to the power d1 and alpha 2 is corresponding to an orthonormal basis of c to the power d2 is your choice. I'm not forcing you to pick what is d2. You can take d2 anything you want. Doesn't matter. Whenever you'll be dealing with such a thing, then you might have a guess what could be d2. But in general, you want to find out mathematically that given a d1, I have to find some psi for something d2. Okay, I can take it off one choice. It could be 2, 3, 4, doesn't matter. Okay, so this is, if such a psi exists, then it can also be written as this. But I know, because I know my rho 1, I know what is the dimension. I can take its standard basis. And once I decide what is the value of d2, I can also choose alpha. So I need to, if such a psi exists, then I need to find the C alpha, the Ci alpha. So this is what I need to find. If I find this one, then I know what my psi is. So I need to find the Ci alpha, which are complex numbers. Okay, correspond to I and alpha, complex numbers. Okay, and of course, some of these Ci's, C alphas equal to 1. Okay, these are the two conditions. So I need to find Ci alpha.